Okay, guys, section 1.6, it's about application of linear system. The question is, we will, there are many fields where the system of linear equation is applicable, right? But we will look into two of the examples, two or three of the situation, two or three of the field where we can apply this, system of linear equations in order to solve the problem. And one of the field that I want to consider is balancing chemical equations. I know that you guys did chemistry in your high school or in college, and if you have done, great. If you have not done, that's okay, no problem. Okay, you don't need it actually. So we're going to learn a new method. So balancing chemical equation, you already know how to do it in your chemistry course if you have taken one. Okay, you might have done in a different way, but here our goal is to apply this system of linear equation to solve this. Okay, let us work on that. All right, example 1. Boron sulfide reacts violently with water to form boric acid and hydrogen sulfide gas. You know that that gas is, smell really bad, really awful, right? It's just like rotten egg. I think you have experienced this in your chemistry lab. So balancing the following on-balance equation. We are given an on-balance equations and our job is to balance it, okay? So how do we do that? Let us suppose that to balance the equation, we need to solve the system, or you can say we need to find positive integers. How many? Suppose this one, how many chemicals are there? 1, 2, 3. Okay, boron, sulfide, hydrogen, oxygen. Okay, altogether 4. So we need to find 4 positive integers. Let us represent that by x1, x2, x3, and x4, so that it will be x1 b2 s3 plus x2 s2o becomes balanced to x3 s3 bo3 plus x4 s2s. All right, so our goal is to find the value of x1, x2, x3, and x4 so that this equation will be balanced. All right, so let me just write down all the chemicals here. So the chemical here is, one is boron. Another chemical is, let me write, another is sulfur. And what is the other? Hydrogen. And oxygen. All right, so I believe we have only 4 chemicals. Yes. Now look at that. So how many borons are there in this equation on the left hand side? 2 borons, right? So you can write 2x1, and there is no boron here, no boron, only there, and equals, and here how many boron? 1 boron. So this is x3. So we have x3, and there is no boron. Okay, that's one equation that we got. Now let us look at sulfur. How many sulfur are there in this one? So here 3 sulfur. So I can write 3x1, and there is no sulfur here, and then equals on the right hand side, sulfur, sulfur, there is only 1 sulfur. Okay, here you see sulfur is only 1. So you can, this is x4. So 3x1 equals x4. Let us look at hydrogen. So hydrogen is right there in the left hand side. There are 2 hydrogen, 2x2, but with x1 there is no hydrogen. So only with x2 equals, and hydrogen, 3 hydrogen with x3. So you'll have 3x3, and how many hydrogen with x4? 2 hydrogen with x4. All right, and then oxygen is on the left hand side. There is 1 oxygen with x2, so 1 oxygen with x2. And how many oxygen on the right hand side? So 3 oxygen with x3. Okay, 3x3. That's it. So now we have 2x1. Let me just write this in a nice way. We have a system of equation now. 2x1 minus x3 equals 0. And from this one, we have 3x1 minus x4 equals 0. From this one, we have 2x2 minus 3x3 minus 2x4 equals 0. And from this one, we have x2 minus 3x3 equals 0. Now we have a homogeneous system of equation and we want to solve it, okay? So to solve the system, consider the augmented matrix. You can solve by any method that you like, but I strongly encourage you to use this, changing it into echelon form method. To solve the system, consider the augmented matrix. Okay, which gives me, okay, this is my x1, x2, x3, x4, and the constant term here. Okay, x1 in the first equation, x1 is 2, x2 no x2, negative 1 x3, no x4, 0. And here 3x1 and no x2, no x3, negative 1 x4, 0. No x1 in the third equation, no x1 in the, and then x2 is 2, x3 is negative 3, x4 is negative 2, and the right hand side is 0. In the fourth equation, there is no x1 and 1 x2, negative 3 x3, and no x4, 0. Okay, now change to echelon form. And let me know what do you get. Okay, guys, I trust that you will be able to change it into echelon form. Okay, so here is what I did. I did this. I started with this one here, right here. Can you see my handout? And then what I did is, I did this R1, and in R1 minus R2, and then all these process that I did. And then at the end of the day, this is what I got. So let me just write down the general solution, okay? So if you have done, then great. Remember, this echelon form is not unique. So you may have a different, numbers there. That's okay. But the final solution should be the same. And let's check the final general solution will be the same. So let me just write down the general solution. So the general solution will be negative x1 as you can see here, negative, let me just write it down. Negative x1 minus x3 plus x4 equals 0. x2 minus 2x4 equals 0. Negative 3x3 plus 2x4 equals 0. And the last term is all 0, so I don't have to write anything. And x3 is free, x4 is free. Okay, from this one, that's what I got. Okay, from this echelon form, I can write the general solution here this way. And solving this, if you solve it, I'll leave it to you. What you will be getting is your x1 will be, somebody already did it in the chat room. So x1 is negative x3 plus x4. So that means, finally you should be getting 1 over 3 x4. Okay, simplifying, that's what you're gonna get. Your x2 will be 2 x4 and your x3 will be 2 over 3 x4, and then x4 is free. Okay, so remember all of them, x1, x2, x3 are positive integer because we are talking about how many. And so there are many, because there is a one free variable, that means infinitely many possibilities. But one of the possibilities is, let us check a simple, the lowest number that will make this x1, x2, x3 all integers. Okay, so let us choose that. Okay, choosing the smallest. In order to balance the equation, you don't have to, there are infinitely many possibilities, remember that. But to make things simple, I'm going to choose the smallest number, the smallest value of x4 that gives x1, x2, x3 integers. And one of them would be, I believe x4 is 3. Okay, so let x4 equals 3. Let us suppose that x4 equal to 3. Then you will have x1 equals, okay, x1 will be 1. x2 will be 6. 3 times 2, 6. x3 will be 2. And x4 is 3. Okay, that's what we got. So that means the balance equation is, so the balanced equation will be, remember the equation that we consider is x1 b2, okay, whatever is that, the equation is, okay, x1 b2 s3 plus x2 s2o gives me x3 s3 b03 plus x4 s2s. So this will convert into, so this gives me, just substitute the value now. x1 is 1, so that means this one will be, let me write it here. x1 is 1, which means b2 s3 plus x2 is 6 S2O, and this will be 2S3BO3, and plus, what is the other one? 3X4 is 3S2S. So this is our balanced equation. All right. Okay, guys, we'll do one more. And this example too, it's about network problem. So the network problem is one of the most important assumption that you need to keep in mind. As a matter of fact, this is also a common sense, that in network problem, whatever goes in comes out. In another word, total flow in, okay, total flow in equals total flow out. This is the fundamental thing that you need to remember, okay? Total flow in, whatever goes inside will come outside. And with this information, with this idea, common sense, let's look at example 2. Okay, the network in the figure below shows the traffic flow in vehicles per hour over several one-way streets in downtown Baltimore during a typical early afternoon. So determine the general flow pattern for the network. What is the possible value of X5? Explain. Okay, look at this. This is a network problem, and this actually represents the street in Baltimore in the US. Okay, Maryland, Baltimore. Now, let us look at the intersection here. So the intersection, one intersection is this, represented by B, another is here, A, C, D. There are 4 intersections. Okay, let us write all this information in a nice way, in a systematic way, in a well-ordered way. So to write the solution, remember our goal is to get the system of equation here as well. Let me make a table, in order to put all these things in a nice way. So let me just make a table, intersection, and then flow in and flow out. So intersection A, B, C, D. There are 4 intersections, and then total. Okay. Intersection A, how many cars are going in that intersection? Let us look at that. At intersection A, can you see the arrow sign? Arrow represent in, flow in. Okay, the 300 cars are going into that intersection from this one. Okay, so 300. And also these 500 cars going into the intersection, plus 500. Any other in? That's the only in for that intersection A. Now, what are the out? Out is, this is out, as you can see the arrow sign. This means X1, and this is X2 is out. So basically, flow out in that intersection is X1 plus X2. Is that okay to everyone? All right, so let's look at B in the same manner. And I actually want you to figure out how many cars into the intersection and how many are out. and I'll wait for a few minutes. Okay, so we notice that in intersection B, x2 plus x4 are going in, and the number of cars coming out of intersection B is 300 plus x3. And at intersection C, 100 plus 400 cars are going in, and then the x4 plus x5 cars are coming out of the intersection. In the same way, at D, x1 plus x5 are going in. Just look at the arrow sign where that is pointing, and then 600 cars are coming out. And the total, if we look at the total flow in, so the total number of cars going into the intersection, into the flow, into the system is 500 plus 300 plus 100 plus 400. Look at the whole system, and these many cars are going in. And then the total flow out, look at the arrow going out, total flow out of the network, the total network is 300 plus x3 plus 600. Okay.
Professor,
Yes.
why do
So the total flow, if you look at the whole system, then the total flow in is, look at that. So this one is in, okay? Inside, don't worry. So you just look at from the outside. So this 500 in, and then another is 300. This is also in, okay? Let me use a, blue color for in and then red color for out, okay? In is 500 and this 300, and in is here, and another in is 400 there. So these are the into the system, okay, into the system. Now what are out? So out is, you see the out is x3 is out here, out is this 300 is out, and 600 is out. That's the total system, that total network that we are talking about. So that's what I wrote.
Okay, I
Total
got it.
in. And now the question is, assuming that there is no accident, okay, we assume that all of the car going into the intersection are coming out. That means they must be equal. So everything must be equal. Now you have the system of equation. Let me write that system in a nice way. All right, so the system will be x1 plus x2 equals, let me write this way. So this gives me 300 plus 500 is 800 equals x1 plus x2. This gives me x2 plus x4 equals 300 plus x3. And then this is going to be 500 equals x4 plus x5. And this is going to be x1 plus x5 equals 600. And this is going to be 800, 900, 1300 equals 900 plus x3. Now, if you simplify further, you have a system of equation as x1 plus x2 equals 800. This guy will be x2 minus x3 plus x4 equals 300. This guy is x4 plus x5 equals 500. This guy is x1 plus x5 equals 600, and this equation will be x3 equals 400. All right, now we have this system. All you need to do is solve the system, okay? So to solve the system, consider the augmented matrix and change into echelon form. So in the augmented matrix for this system, let me write all the way here. So augmented matrix will be 1. Okay, this is your x1, x2, x3, x4, x5, and then the constant term. So the first equation has 1x1, 1x2, no x3, no x4, no x5, and this is 800. No x1 in the second equation, no x1, 1x2, negative 1x3, and 1x4, and no x5, and this one is 300. X1 is 0, no x2, no x3, x4. In the third equation, x4 is 1, x5 is 1, and then right inside is 500. And first, second, third, fourth equation has x1 is 1, x2 is 0, no x3, no x4, x5 is 1, and the total on the right hand side is 600. And in the last one, you have no x1, no x2, x3 is 1, no x4, no x5, and this one is 400. So this is the augmented matrix. Now the thing is, you need to change it into echelon form. Okay, change to echelon form. I trust that you all know how to change it into echelon form. And if you change it into echelon form and write the general solution. Okay, let me just write the general solution. I leave it to you, and your general solution will be this. You will get x1 equals 600 minus x5. x2 will be 200 plus x5. x3 is 400. x4 is 500 minus x5 and x5 free. All right, that's what you get, your general solution. And okay, so part A is done. Now in part B, what we are supposed to do, let me go back to the question, what we are supposed to do. In part A, determine the general flow pattern for the network. That means we need to find the general solution. That's what we found. Now part B, what is the possible value of x5? Okay, what is the possible value of x5? Let's look at that. Part B. So remember, just using common sense, a negative flow in a network branch, corresponds to flow in the direction opposite to that shown on the model. But since all the streets in this case, all the streets are one way, okay, the streets are one way, so none of the variables can be negative, meaning x1, x2, x3, x4, x5 must be positive. All of them must be positive, non-negative. Okay, so here all the variable x1, x2, x3, x4, x5 must be non-negative. They cannot have negative. So that means that leads to the fact that x5, as you can see, x5 must be less than or equal to 500. Because if x5 is greater than 500, for example, if x5 is free, and let's say x5 is 600, that means you're gonna get x4 will be negative 100, which is not possible in this situation. Okay, we're talking about the car going into the street, number of cars that we're talking about. Okay, and so this must be less than or equal to, x5 must be less than or equal to 500, because x4 cannot be negative. All right, okay, so we are done with this example, and there is one more example which is very similar to this, and I'll leave it to you guys, example 3, and you try this on your own. And if there is any questions or concern, then we will be working on this in our next class. All right, this much for today.